Alright, in this video we're going to look at indefinite integrals or antiderivatives of x's that are raised to a power. So let's take d over dx, which is derivative, of, say, x n plus 1 over n plus 1. Now, if we took the derivative of this, and my mistake, we should also add plus a constant, and close bracket. We're going to go ahead and take the derivative of this. Well, the derivative of this is easy. We're going to use the power rule. We're just going to bring this down here, up at the top. So we'll have n plus 1 with x times x over n plus 1. Now, when we're doing the power rule, remember you subtract from this integral here. So it'll be n minus 1, so it'd just be 1, just should be n. Now, when looking at this, you'll see that n plus 1 is at the top and bottom. So in this case, you can go ahead and just cancel those out. And the derivative of a constant is, of course, 0. So in the end, you only have x to the nth power. Now this is fairly easy enough. Now remember, when doing this derivative here, you got to make sure, if I can actually draw an arrow correctly, you have to make sure that n does not equal negative 1. Because if n did equal negative 1, it would put a 0 in the denominator, and that would make it undefined. So we can't, in respect of x, n can be any number except negative 1. So knowing that, let's look at a indefinite integral of power. Now let's say if we are taking the indefinite integral or antiderivative of, say, x to the nth power dx. Remember the connotation here and here, they both have to exist because they act as parentheses. Now this is going to be indefinite integral or antiderivative. There we are. Now, when we do this, we know that we answered it at the top. So basically, it's x n plus 1 over n plus 1 plus a constant, because we want to make sure we cover all bases here on any number added to this x. And remember, in respect, this n cannot equal negative 1, because then it would make it undefined. So when we do this, we figure out that it equals the same thing as that there. And we figured that out to be just x to the nth. So if you wanted to go back and check, it'll be x to the n, which is what it is here, what we're finding the indefinite integral of. Now, this is all good, but let's look at an example to see exactly what I mean by this. So let's take the indefinite integral of, say, x to the 4th power dx. Okay, so what we're going to do here is, of course, use that same formula. We had x to n plus 1, which is 4 plus 1, which is 5, over n plus 1. 4 plus 1 is 5. There we are. And then we need to encapsulate all other possible numbers that are going to be with this, so we're going to add plus c, because we need that constant to represent any other number that can be added to this function. So this is the answer right here. Now let's look at a more difficult problem. Say if we had the integral of x, well, let's erase that. Say if we have 5x to the 4th power dx. Now what we can do here, since these act as parentheses, you can actually pull out the 5 in front. So really you have 5 to the integral of x to the 4th dx. So let's go ahead and solve this. Let's see, we have 5. Now if we took the integral, it would basically be x 4 plus 1, because you have x to the n plus 1 power. So 4 plus 1 is 5. And then you have that over n plus 1, which is also 5, because it's 4 plus 1. So 5. And then, oops, sorry, you can't forget the constant, plus a constant. So you can further simplify this by distributing, because you already have the integral right here. So why not go back and distribute? So what you have is 5x to the 5th power over 5 plus 5c. Well, we know that a constant, the number here is the constant here is a number, and if you multiply that by 5, it'll still be a number. So this will actually just be 0 when you take the derivative of it. So it's just going to be a constant. So you don't need the 0, you don't need a 5c, it's just going to be c, because it's still going to be just a number. And also here, you can actually cancel the 5's here. So what you have is x to the 5th power plus c. And that is your indefinite integral.